Yeah, I think I also should do this. I mean, what's the difference between 100th and 1000th? Especially since previous might not exist yet. No, that does exist. Well, yeah, I need 3 samples. No, I'm not convinced. So it was assert if previous is not less than total number of samples, which could happen if, I guess, let me just see where this is being incremented actually. This is incremented here after calling add. Yeah, normally it would be incremented if the sample that I add is not almost equal to the last sample. Okay, now I don't know anymore where I should begin. Previous. Okay, so the only thing I really know sure is that the number of coefficients equal to 5. I'm not sure if that guarantees that previous history previous is not asserting. I'm pretty sure that that could happen. We can just test it out, I think. Yeah, let's just test it out, man. I think if I just start at the minimum, then we'll see this problem happening or not. Okay, let's see. The minimum is in minus 7.75. So if I begin there, that might make us crash even. It's like, what is the chance that you drop infinitely precise on the minimum? Not crashing. crashing. This happens because of a not a number. Yeah, that's what I meant. It just too precise. Yeah, simply because those are equal, obviously. Yeah, problem. I don't think I should have ever run into this, because it is that current minus previous equals 0. That's the reason why we get not a number. Either here or here, I guess. Mm. Why can I not keep that in my on my screen at the same time? squared you can negate both sides. I get a times r minus p squared plus q minus s can make this p minus r. P minus r squared times a plus q minus s all divided by p minus r. Oh well, I guess you just left the a out. I'm not going to edit it. It's his error. So you can fix it or you can leave it. I don't care. Yeah. Okay. Mm-mm-mm-mm. What to do when there is no parabola? I would say, well, if we have 2 points that are just, it's the same. Oh yeah, that was the whole point. So I don't think this should happen. This should not be so small that I can't divide by it. Yes, yeah, well, you can ask. Theoretically, I don't want to add anything to the history that is already, well, that is super close to the previous value. So why do I end up with two values that are exactly the same? Making this 0. I think the reason is that I do have a provision since today in add. If the new sample is very close to the current one, don't add it, just replace it. However, then I used another trick that the scale is set to 0 when it is not known. And if the scale is 0, then this is never going to be less than, of course, because just this absolute value is not less than 0. So this is false, and therefore it adds it anyway. Yeah, interesting question. Does it have anything to do with C++? Normally I go into questions about my work, or better, what you see on the screen. But asking for what the hell is this even? Sorry, I had to laugh. It doesn't help that I see the last word. I can't see the last word. They put it here. I'll show you. If I can do that safely, I think so. See, they put this thing over the text, so now there's nothing there, but I couldn't read AIML. So I see blockchain and market, and I think you're asking me for a stock market investment advice or something like that. And if it's about job advice, then I don't know either. I only know C++, nothing about jobs or stuff. So I think that what is going wrong is that I get here with the sample being exactly equal, while scale is still 0. Now you could still say make this equal or less than or equal. Then I wouldn't add it. But yeah, even if it is 10 to the power minus 30, that's then no longer equal to 0. Either, and that it's still, too far off. So maybe what I should do is say that the absolute value is less than, maybe if it is 0, I should just actually return 10 to the power minus 30. It's it gets or 0, I meant, dirtier and dirtier. The feeling I'm patching one hole with the other at the moment. Excusez-moi. Okay. So now what did it? Replacing. Yep. So I drop it in the minimum. 0.0, my initial attempt is exactly at the minimum already. And then it replaces 0.0 with what it measures. Because, yeah, it's already in the minimum. And otherwise we have 2 in the minimum. And I don't want that. And the result is that my money is on crashing still, or asserting. No, I lost money. But it doesn't climb out of it. It's just infinite loop now. That's also not good. It's kind of not detecting that it is in the minimum now. So the slope is 0. Therefore we don't make a step. Therefore we stay at the same place, which then is not added to the history, and therefore everything is exactly the same as before. I guess that what we should do in that case, okay, my music is bothering me. I'm gonna put on be nice if my browser reacted if I click on something. Click, 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 reload. Okay, I'm back. So what I was doing, yeah, so if we are already in a minimum, I definitely don't want to add it to the history. This is correct. But then how do I detect that I am in the minimum? I guess that happens because it's still going to be very big. I mean, dividing by 10 to the power minus 30. No, it wasn't added. What? Oh, wait a minute. Yeah. So I have only 1 point then, because not adding to the history means that this is stuck on 1. We have only one thing in the history, so the number of coefficients equals 2. So we are here. And then this is the point where I should detect that nothing changed, because the derivative is 0. Well, I'm not detecting anything actually, I'm just setting this to 0 as well. So now I have a constant value. The parabola is now just a constant. And then I have to dig it out of that again. We never get here though. And so therefore we do this. No, that's just finishing it. So it's still just a constant. Door the parabolic approximation, I guess that did it. Did that right? Just a horizontal line, the constant. And then keep going is true. If a number of coefficients is 3, then we make decisions. Well, not really we make decisions. I think what we do here is... yeah, in this case I have a pro, so I just jump to the vertex, I guess. Might suffer from the same thing, because the step here might be incredibly small. Okay, we don't get even here, and we definitely don't get here. And keep going is set to true. Direction is not set, so we get here, I guess. And now we add 0. Because step is 0, because the dl dw is 0. And that is the problem. Then we don't get anywhere. So what is it that I would have liked to do? Yeah, that is a nasty question. I think that basically I did reach a minimum before we had enough data points to say anything about fitting fourth degree polynomials. So I should, I think that the right decision to make here is to just not be happy with the starting point, period. So I think what I could do is I have to make some kind of step. Larger than. Can already detect it here, maybe. Can it happen at another moment? Theoretically, I guess it could happen if scale reaches almost 0. And then we reach a minimum, which is super unlikely, but it can happen. It's kind of a mess, I must admit. Shit. Yeah, this is not good. I don't know what to do. It's oh, I'm not sure, but it looks like it's the same as apps step as this problem here. Well, not really, but okay, here's the step is very small. And then I try to fit a fourth degree polynomial, which is not possible because we don't have enough data points at the moment. If it happens immediately. So the result is more or less that we don't have zeros. No extremes of the fourth degree. Which means I just keep my scale, but I don't have a scale yet, which is also annoying. So we don't have a scale, and then we figure out that, well, we don't have zeros actually. Okay, skip that, and we're doing nothing really. Oh yeah, that was another problem. If I do not have two zeros at all, then I'm currently not detecting that we are not making no progress at all anymore. I thought that was a different problem, but it looks like the same problem. The reason I only want to go into this scope is because sorry, the reason I only want to go into this scope while the number of zeros equals 2, that's the zeros of some parabola that I calculated there, is because I'm trying to find the best zero here, the best of the two. Imaging having no zero at all. Yeah, that simply means that I can't use my fourth degree polynomial algorithm. But let's look at what that does if I do have a fourth degree polynomial and I can't use it. It's almost the same thing. Nothing. Okay, maybe if I run into that problem, let me think. It's something, this doesn't exist. What I want to do, what I normally want to do, is continue in the same direction with an arbitrary step. Well, a step related to the scale. In this case, we have nothing. Yeah, that really doesn't belong here, I think. I think it's a startup problem, what I have now. Startup problem belongs to this scope here, where I just have number of coefficients equals 2. So the startup problem is to be detected as this being too small. Did we drop into a local minimum? This is starting point. I'm going to create an epsilon, I think. Oh, that gets a nice color. There is an epsilon already. Yeah, something else, right? Tja, I have a lot of epsilons. Oh no, 3. Let's make a new one. Yeah, if that is the case, then maybe I should just make a step in absolutely arbitrary direction, arbitrary size. Who cares? Any step will do. Yeah. Now do code here so that the result is that we make a random step in a random direction. And obviously keep going is still true, I hope. Or you're telling me that it isn't. Going. Keep going is true here. But I'm currently up there. Yeah. Okay, let's delete that here and put that above. No, maybe not. Damn it. Keep going being true means do the old gradient descent thing. You're just learning rate times the derivative step. I can't do that either because we don't have a derivative. Nor do we have a learning rate. We don't know anything. So maybe it should not be a Boolean then. Could make it an enum with 3 values. Either keep going, don't keep going, or something. And then I can add to that the thing, or do a random something. See how often keep going is just being set to false here, and then we tested there. So that seems to make sense. Yeah. Just gonna define it here, I suppose. That's still that same scope. Enum. Step kind. Let me get the class. Enum class step kind. And then we have the following possibilities. How do you call the old gradient descent thing? No nonsense gradient descent step. I used to call it keep going. Maybe I should call it keep going. Ha! This is to keep going. Let's subtract learning rate times derivative. Oh, he's still awake, and that's 19 plus 3.5 is. Hey, Ninja, how are you doing? Yeah. What is the other one? Keep going. Done. And then we have a random is like a thermal jump. Yeah, I'm gonna call it random. By the lack of a better idea at the moment. Was already updated. That means that's where I currently set keep going to false. So what is updated then? New sample. Yeah. New sample, and new sample is defined where? All the way at the top, so we definitely know what that is. So it was already updated. And then step kind is keep going. No, I'm going to call it step kind, of course. And because it is an enum class, we have to put that in front of it. Yeah, and then I have to fix the code. So I have the step kind done whenever we set it to false. Actually, something totally different. And step kind done. Okay, I forgot. What did I call the thing? Step kind, yeah. Step kind is done. And then that seems to belong more to just after we change the sample already. And then I have another keep going. Wait a minute, let me first copy that line. Here's another one, which then also is moved up to there. And do I have another one? Well, actually, it's set to true there. That's interesting. And then here we can do if step kind equals step kind keep going. So I didn't change anything. I just allow step kind, which used to be called keep going, to have 3 values, you know. And if it is done, then I don't do anything. But if it is keep going, we do something. And now I can add if step kind equals the random, then we do a random step. Right. So that is something that I should be doing here because, well, we drop in a local minimum, we don't know anything, just continue with some random step. But then after leaving this scope, yeah, we must get to the end, and I'm not sure that happens. So I'm going to have to test step kind again, I think. Number of coefficients, okay, where did I come from? Here, number of coefficients equals 2. And then we leave that here. So number of coefficients is not greater or equal 3, so this is skipped anyway. Oh, we do this. Yeah, that's okay. Can draw it, no problem. Set, so I'll draw it actually. If it is 3, it's not 3. Is it 5? It's not 5. Oh, no, that works. We do get here. And now it's not equal to keep going, but it is equal to skip random. Therefore, now we can do a random step. And then my random step is going to be positive. I'm positive, right? Let's be positive. How large is our random step? No idea. No idea. I guess it doesn't really matter. It's random anyway. Well, random between fat quotes. But if I make a super tiny little tiny step, then it's not working really. I think I would like to do something like maybe I should just assume that the derivative was 1 and then we add learning rate. And then I mean, and suppose the random step learning rate is super small anyway, by coincidence, then we get nowhere. So I do have to increase the learning rate afterwards, I think. At least now we get somewhere. Yeah, okay, so they should kick us out of the minimum, at the very least. Oh, I didn't define my epsilon. Yep. Okay, what is epsilon? That's as hard as the other one. I mean, I mean, you don't know what you're dealing with, in which scale. We don't have a scale, so I don't know. Epsilon can be anything. So on the safe side, I thought, let's use 1 to the power minus 10 to the power minus 30. Very small, but if it's larger, then I can divide by it. So then we just go that way. I think anyway, yeah. So I'm gonna set that too, and I think I have that more often. So here I can put an epsilon. And do I have another one? No, that's it. Okay. No, then we need an epsilon to be defined, it seems, in global scope. Oh, I'm not going to do that. So to put it in scale, public, static const expression, double epsilon. 1e minus 30, and then I'll just have to steal it from there at the other spot as well. Scale epsilon. Exciting drum roll. What will happen now? Ta-da! We are in the minimum. Okay, I'm gonna press space and it's going to do ding. Nothing. It's not doing what I wanted. That's for sure. Oh. Really? I mean, I'm looking here and it seems to be very small, but not less than 10 to the power minus 30. Yeah, this is not working. But, okay, now I have a problem. So on one hand, it thought that it's not 0. Probably in this range. It's not less than 10 to the power minus 30. So, yeah, well then, is there no problem? No, there was no problem. We did not crash. We could calculate it. And there is, I think, anyway, I don't know. But then the adding it to the history is saying, yeah, no, let's not add it to the history. So we still have only 1 point. And there is no change. Kind of confused here. I think I want to run this in the debugger. You definitely should get here. Maybe set a breakpoint at 683. Space. Right. Print number of coefficients. We have 2 coefficients, probably because, I don't know, we have just 1 sample, I guess. Next. And this is, that gives me the derivative. Just run it. I think that gives me the derivative in minus 7.75, which maybe doesn't fit exactly in a binary number, and therefore we get some kind of round off error. You see, it's totally not 0, while it should have been. Maybe that's it. It's the value is like 4 or something. I mean the height here. I mean 4, 3, I don't know, but not 0. So 16 is about the precision of a double. So the epsilon is maybe a little bit too optimistic. I can divide by it, but yeah. I'm not detecting floating point round off errors here. But okay, the intent of epsilon was indeed to be ridiculously small. So I can live with it that it's not being detected. But then, why doesn't it recover? Well, it doesn't recover because we don't do that, do we? What? Okay. Oh yeah, okay, that. Draw the thing. So that's our fitted polynomial. It's a straight line, horizontal. It's a constant. The number of coefficients did not change yet. Yeah, and then we get to keep going, and it does work because it's not 0. The step is not 0 either. We're doing something. And I think my learning rate should indeed be doubled every time here. And it's still going to be take a very long time, I think. Yeah, still doesn't really make sense. Doesn't make sense. Minus 17 is just way too small. maybe I should compare this step with the absolute value. Epsilon is more for if stuff is around 0. But you have two kind of errors. Let's say the relative error and an absolute error, of course. And a relative error is, let's say you have 5 plus or minus 0.01. And then you know that it's pretty accurate, but it depends on the 5. If that 5 had been 0.003, then that was super inaccurate. So in order to know if your error is good or not, you can just divide the 5 by the error, and then you get some indication of how good or bad the error is. So in this case you get 500, which is good. It's a small fraction of 5. While if this had been 0.002, then we do get 0.2, which is clearly very bad. So even less than 1. However, at some point that breaks, because suppose that the whole error is 0.01 anyway. You can't expect it to become any better than this. Okay, that's the absolute error, not a relative error. So even 0 would still be very good. 0.1. I mean, the 0.1 is per definition good now, but I would agree with that if it is a 5. But if we are randomly at the constant 0 plus or minus 100th. And suddenly I'm screaming that we have an infinite inaccuracy, which of course is not true. So that's what I said. There is two kinds of errors, so we have to check on the relative error, but also the absolute error. And I think I want to use the epsilon for the absolute error, but we also have to check for the relative error. And then in this case, I would say that we are at about 3 height, and then 10 to the power minus 17 or 16 is just way, way smaller than this 3, and therefore it's 0. Even though it's not less than e to the power minus 30. But yeah, on the other hand, I guess it could happen that also the vertex is at a height 0. And then maybe I would still get 10 to the power minus, or would I? I'm not sure about that actually. Then all the inputs are 0. We're talking about 2 points here. No, well, yeah, I don't know. I don't know. Just talking to myself anyway. I think I have to detect that this is too small. That doesn't make a sense. Even if we would get out of this, it just doesn't make sense to make this step. And the reason being that the sample is currently having a value of indeed almost 3. Sorry, yeah, it's a L of W. Okay, let's detect that as well then. Can I maybe make a function to do this all in one? let's, okay, what do I want to know? I want to know if this value is very small. So something like scale almost 0. Well, that looks good. It doesn't, I don't know. No, then I can't draw it. I have to assign it. Oh well, I'll just paste it in here then, I guess. Call it derivative maybe. Yeah, I'm gonna add a new, because it doesn't really read well this way. So the derivative is this. Well, can I just repeat that because it doesn't calculate anything at all. It doesn't calculate anything at all. It just returns something that is fixed. Duh. I changed my mind. In that case, I'm passing that. Might as well do that here then. Yeah. Let's pass this. Why the hell am I passing L here? Something does not feel right. Gradient descent, is this is sample. Okay, so this is just using initialized. Yeah. Okay, I changed my mind again. Double const TLDW is that. I'm going to move this down. Okay, it reads better. So I have to write to almost 0 now for some double value. Scale, some static Boolean, almost 0, double. Well, it was originally step. Written high. I can not do the relative error if I don't have the absolute value of the other value. It's originally a W value. So if step is less than epsilon, then it's definitely almost 0. But also If almost, no, it is not it. Can use almost equal. It's kind of, no, it's not the right thing. I don't want to know almost equal here. I just want to know if step divided by W is very small. Well, yeah, I don't like divisions though. I'm deleting the wrong thing. If step is less than something small times W. Something small being, yeah, I don't know. A millionth, I think, is already small. Don't want to make one. Just change the value 1/millionth. That's ridiculous. Right? Yeah. I could even make it 1,000th, I think. But okay, let's not exaggerate. Do I have to pass the thing that is being changed as well now? Sorry, the step. What am I updating? I've got what I was updating. This, the new sample. Ah, right. Is that already defined up here? Yes, that was defined way up there. Is it already, oh, wait a minute. That's not where I wanted to be. Here. What did I say that it was? New sample? I'm not convinced that new sample is already defined at this point. Or is it? I mean, it's defined, but does it already have a value? Probably, because I added it to the history. Oh yeah, most definitely. So I initialized a new sample with, yeah, the very first value, which I just set at -7.75, which is in the minimum exactly already. Everything looks good. Now it should definitely detect that we have a problem. And after it compiles. I can't convert to new sample. So I must take W, I guess. The E wanted to be independent. Independent. No, really? What the F, dude? Nope, I don't think it made any difference. Okay, back to GDB. What was the line number? 688 is the line number now. It's already there. Oh, break main. Yeah, whatever. break 688. Continue step. Yeah, number of coefficients is obviously 2 because you just entered it. This is still, yeah, this is 10 to the power minus 16. I feel I have forgotten a standard absolute, but that can't be a problem because it's positive. W is negative. W is negative, so it's a standard absolute problem. Anyway, let's go in it. Yep. A step less than a negative number? No. Okay. Zip. Step is positive, right? No, step could also be negative, I think. And here it's even worse. Step could be negative. W could be negative. Let's do the correct comparisons, yes. And we wait until it compiles, and then we just run it without GDB because we are convinced that now it worked. Ta-da! It worked. So now we did make a step, but the learning rate is very randomly 0.1. So it did make a step. And the result is that now we're not in the minimum anymore. So now it did fit a parabola. And we have a scale. Very small scale, but hey. Well, that's weird. Well, it's not that weird, but it's still adding the same point twice now. Can that go wrong? Yeah, it's going in the opposite direction, so I'm comparing the new point just with the last point, and therefore, it's different, therefore I add it. But the point before that, point 0, is also at that value. So now I still have 2 points in the history that are exactly equal, which is going to be a huge problem. Because I'm using 3 points to do my parabola fitting. Well, not polynomial fitting. So what happens if I press space? Oh. It just worked. Confused. Let's see here. Fourth. Fitting a fourth to be parabola using samples at, yeah, twice the same sample basically. And we don't even get weird numbers out of it. No, that's strange. It is very strange. Why this is happening, I don't know. I don't think that's necessary anymore. Or is it? it's wrong also. It is wrong. So you have 2 points here very close together. The right one is minus 7.75. And the thing below the dotted line is minus 7. Oh, we did. Oh, sorry. Actually, it's not true. The minus 7.65 is the solid line. Minus 7.75 is the dotted line. So we did step in that direction, the positive x-axis. Then we fit this parabola. So why do we call this parabola? We fit this 4th degree polynomial, which has an extreme here and there, and this extreme is a little bit lower than that one, which give us the hope that also the minimum after it is deeper. So we go to the left towards the one that is the lowest. And well, we do that like in one step. So now we're in 4. And then we add 5, which is simply in the same direction using the learning rate times the derivative. And then I don't think 5's used yet. Oh yeah, I was falling over the duplicate. The point is that in order to fit something, I use the last 3, well, something to fit the 4th degree. I do fit the last 3 samples that we have. I'm going to use 4, 5, so I need a 3. That is, this is the last thing in history, and then the previous one, and then the previous one should be the one that is closest, which is the one under the dotted line, which is the minus 7.75. So it was actually correct. I'm going to try to go the other way, because I have the feeling that might not work. It's random anyway. It's not so random. No. Specifically pick a negative direction, huh? Blip. Okay, we did 0 again, and now we go in the negative direction. Little step. So now we get it to minus 7.85 instead of 6.5. And then we plot a parabola through that, and you get the same problem, because I really don't like this, that it is still added to the history, still having 2 points that are the same in the history. And because the next one, I mean, previously we didn't know anything, so we just made a little step. But now we have a parabola, so we can find the vertex of that, the minimum. And that minimum is minus 7.75. So now it's going to say, oh, but we don't move. We're already there, and now we found again the same point. Which means that it's going to say found minimum. What a bunch of talking here. Really? It's not saying anything. Oh yeah, it's saying minimum reached. That's after a long while. Yeah. Well, okay. Maybe a bit typical output is missing. Because why is it starting to do this? I'm completely lost. Maybe I should step through this with a debugger, because it seems to take a long time before it actually starts doing something normal again. Okay, so quit this. Let's run it again. And now, how many spaces do I need? 1, 2, and then the third space is doing all that. Oh, it already had done all that. Okay, now maybe I can follow it. I don't know, I thought we were up here or something. So this was already printed, and then I let it continue, and it can now determine again a parabola based on 2 and 1, and those were the, I guess 0 was in the minimum, and then 1 was a little bit to the left, and then number 2 is again in the minimum, right? So 0 and 2 are actually the same point, both in the minimum. But this new parabolic approximation is still based on the point 1, which was a little bit away, but a little bit to the left. So no problem there to fitting the parabola again. Finding the extreme, which is still minus 7.75. Calling, update on scale. Scale set to minus 0.1. This is just still very small. And then it sees that this minimum that it finds now is it's just the same parabola. So the minimum is still the same. So it wants to make a step of size 0, which is then the 2, so at 0, and then 1, which is to the left, and then 2 in the middle, and then 3 is also at that same point, because that's just the minimum, and therefore from 2 to 0 is no progress at all. And therefore it starts fitting a 4th degree parabola. And I'm surprised that it works, because it has to the same points. But okay. This then gives us the green curve, which has a minimum, or sorry, an extreme here and there, and then apparently this one is picked because it's a little bit lower. Well, that's surprising because previously that one was a little bit lower. So that's why I went that way. Apparently the one that is lower is purely determined by the side that you step to. So we step that way, we go this way, and we step that way, go the other way. Very annoying. That's not what I wanted to test. Okay, so how else can I fake this? I just have to enforce picking the 0 on the left. I don't want to go to the lowest, I want it to go to the highest now, because that's to the left. Pick the other one. Okay, boing, doing, doing. And now it's going to this one. Ta-da! Okay, that's what I wanted. So, fourth degree parabola, with those zeros, and it says minimum reached. We already knew that. Replacing is 3.2 with that because they're equal. Direction is set to up. We're now going to find a maximum. So W to found extreme minus 15. The best zero was haha minus 15. Because that is larger than the other one. Yeah, oops, well. Delta is minus 7.9. That's the step that we make. The best minimum so far is, of course, the minimum, the only minimum that we just found, which is here, which is actually best minimum. Re-adding closest sample to history. This is what I wanted to test. And it works, apparently. Yeah, okay, now it's picking this one. Huh? Yeah. Okay. I think I worried about it for nothing, so that part just works. So now if we drop in the minimum, it seems to just continue fine. So let's go back to the previous problem, if there still is any. Note, by the way, that this is a special test because it exists of two parabola which are connected around here. You can see the little wobble here. So this is one parabola, and then this is another parabola. And it tries to find a minimum by matching parabolas, so extra confusing. That is the gradient derivative. Therefore we go down, and we have now one more point and the derivatives of those points, by the way. So now we can fit a parabola, and so you can see this is a parabola. So if it tries to fit a parabola with 2 points on a parabola, it's going to get that parabola. But here, as I just told you, is a different parabola. It just doesn't follow that line. It follows another parabola. So using these 2 points, we fit this parabola and we find this minimum here. Now we don't know anything yet about this part. So it's logical to assume that this thing is going to stay a parabola and the minimum will be there. So that's what we jump to. And then we're going to fit a parabola through 1 and 2. And note I also keep a scale. The scale is, well, the change in W over which the thing just remains a parabola, more or less. I mean, you really need to know if it is 1 or 10 to the power 10 or 10 to the power minus 10. Now at least we have something in the neighborhood of, you know, the scale at which stuff changes. Okay, fitting through 1 and 2, we find a new parabola again. And the minimum of that parabola is here. Yet we go to 3. I'm making really weird faces now. For those who have watched more often, I have worked off stream more or less on the scale, so the scale is now working. It does keep the old one instead of now using 1, because as you can see, the old parabola, which is this lighter color red here, the previous parabola, is almost the same around 0, 1. So you might as well keep using that, obviously. So yeah, why decrease the scale while you know that it's just parabola all the way till here? And I have no idea why it chooses 3 now. Can they understand that from here? Minus 3.4. Seems to think that that is the vertex, but huh? Oh wait a minute, sorry. The one is 3.4. That is this one. So it's this is clearly 3.5 minus 3.5. This is more like minus 6 or something. Yeah, or something. Yeah. Oh, just making a step. Okay, never mind. Never mind. So it's... Yeah, okay, I forgot my own algorithm. It's not going to the new minimum. It sees that the new parabola is not a good fit, so it just keeps going in the same direction using a learning rate, which is doubled every time. So I think that next step might even be like all the way here. No, it's not. Okay. I don't know. Anyway, this was a fit of 3 and 2. So fitting 3 and 2, and 2 is already on the kink is here. So this is the new parabola, which is now found. And therefore we know exactly what the minimum is. We jumped there, and I have still no idea why we jumped to 3 before, but maybe I don't know. No. It's my program is starting to become smarter than me, I guess, because I can't follow it anymore. Okay, so now you found the minimum, or you don't know yet. So I guess space again. Then it is something like maybe you should print a horizontal line or something every time I press space, because I completely forgot where we were. You know, I'm going to do that right now. Seems handy. Block. There's no block. Block. Press space and return from this function. So then we print a horizontal line. Mail. Yeah. Completely correct. Ding 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 boing 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 boing. I think we were already here. And then the next step is that one. Yep. Okay, so that's where we were. Parabolic approximation is still the same, of course, because we already found it before. It's exactly the same. And now finally we figured out that it is the same. Therefore, absolute step has become very small. So here we still made a step of almost 2.5. And then we continue, and eventually we see that there is no more improvement to be made. At that point, we are fitting a 4th degree polynomial using the values and derivatives of 3 points, namely points at those values, among which the minimum, which looks like that, derivative is then that, and if you divide that by the 0 that we found, you get a quotient, which is a 2nd degree polynomial, from which we can calculate the zeros if it has zeros, but it does not have zeros because it's the blue line here, and it looks like I don't know what it looks like. I would say a horizontal line, but clearly it's lower here than there. So why it's not going through 0 eventually, I have no idea. No, it can't be it. This is positive. So I guess it's a horizontal line that looks like a 0.4 everywhere. Just 0.4. What? That doesn't look like 0.4 at all to me. This is 0. This is 5. How is this 0.4? I'm so going to ignore that. Oh, times 10. I remember. That thing, the quotient is always so small that I draw it times 10. So it is 0.4, but then I redraw it such that it ends up in 4. So this is probably 4 then, I guess. 3, 2, 1, 0. Exactly. See that? Yeah, okay. Anyway, it's a horizontal line, and there are no zeros. And then finally we make a remark about 0.5 being the new minimum. It seems a bit late, if you ask me. It's almost confusing by now, this debug. I did refuse to add it again. 4 was already there. I think like this. So the point that we refuse to add and instead we replace the 0.4 in the history with that value. Is 5 is the new point that we found after adding this value to the last sample. So this value is already known, like here. That's the value. It's just the end of the loop remark here. Okay, I'm gonna look where that is and why the hell it is that late, because it keeps confusing me. Okay, that doesn't work. Even that doesn't work. Now we're going to be smart. Yeah. It wants to outsmart me. Oh, warning. Stray before dash. Okay, it has definitely outsmarted me. Oh no, there it is. Bleep, boing, ding. No, that's W delta. Everyone that walks past my house looks inside. Like pain in the neck inside. Has nothing to do with my microphone. They can't even see my microphone. No, I think it's the monitors. Too many monitors. Too many monitors in the middle of a living room. Yeah, okay. So we're printing this like super at the end. Maybe I should move it up. I could move it up as soon as new sample has been updated for the last time. And the reason I printed here, I guess, is because new sample might be updated there. Or here, but it's not when, yeah. Okay, let's do it like this. In both of those cases I want to print it, so if step kind is unequal done, then I print it. And then if I have set it to done, then I want to print it earlier. Meaning this line must be printed more around the time that it's actually being updated here. The new sample to extreme problem, blah, 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 and then I print it again. What about pretending we didn't do that net? No, I don't have to pretend. We can move it one line higher. Put it here. And then I can type setting, because it's yet to happen. You want to the extreme all way of parabolic approximation. And then we make that a column and no information. But that information is then printed here. And then the other, I think there's only one. Yep. And the other one is there, which is kind of the same thing. So print, and then this is saying set new sample to the extreme. It's the same. Is that correct? It's not correct. Well, actually, when it is the beta inverse times something, it is correct. So, okay, copy that. Step. But surely I change it more often as a result of something else. Now we have the learning rate, which is at the bottom, and this going to the extreme of the parabola. And I have the zeros. Oh, that's in the neighborhood of the best zero, and I'm just doing that a little bit different, like here. It's not no error stuff. It's a W to found extreme. Okay, that's the output then. We should just look for new sample equals. No, no, I shouldn't, because that's the only line. What? The other ones are I think plus or minus. Yeah. Okay, it should be less confusing now. I think the place where it is printed, because I'm just not printing it. No, that's not true. That's not true. Also one more. Good. So parabolic approximation, the same as what we had before. Now it prints it up here. Yeah, so we've recalculated parabolic approximation, and then we're going to set a new sample to the extreme of the parabolic approximation. Therefore, it changes from that to that, which is just not moving at all. And then scale is updated, and then we find that the absolute step is indeed almost nothing. And therefore, we do a fit, which then has no extremes. And that's not good, because we don't know anything else after that. Stuck again. Yep. That the scale became less is, I think, correct, more or less. Although you would think that why? Let me think about that again. So this was a nice scale, and that scale is still kept because I just didn't know what to do without any zeros, so I didn't touch the scale. But if I now press space again, then it's just finding the same parabola again, and then it changes my scale. Why? I should do that. Oh, I reset the scale. Oh, wait a minute. Yeah, the scale was reset. Resetting doesn't delete it, so maybe I should delete it because now it looks like it's still there. The scale was reset, so it has to find a new scale. There's no scale anymore. And the new scale is then just the point that it uses to calculate this problem. The reason I reset the scale is because I'm going to fit a fourth degree polynomial. And maybe I'm just being too optimistic or something. Because if then you find the zeros, I want to set the scale to that value. Nah, I think 37 is okay. I don't think this is a problem. The problem is that we're just stuck in this minimum and we're not realizing that we're done. Okay, what should I do? No zeros. I think what I should do is continue in the same direction as we were going, with a step equal to the size of the scale, or larger even. Let's just begin with the scale itself. Doesn't matter that much, I suppose. 2 is no zeros at a problem point. Ta-da. And see, scale is reset here. We just keep the scale because we don't have zeros. And then we don't do this. And then we don't do anything at all. Yeah, this doesn't make sense. Yeah, you see the comment. The comment says, did we reach the local extreme? That question is answered by the fact that the absolute step was super small. It has nothing to do with whether or not we found zeros. Nothing whatsoever. So this part should go. If we did not reach local extreme, then we can just continue, as we did before. But otherwise, something has to be done, and we do that in this block. And then we say the maximum has been reached, or the minimum has been reached, in this case. And it is added, or not, or replaced. Then we change the direction. It's the up-down direction. So now we're going to find a maximum. And then we're trying to find the best zero of the two zeros that we don't have. Yeah, so this output here, it's just debug output, but that should only be printed when we made a decision about which way to go based on the fact that we have two zeros. And I deleted what? Number of zeros, makes sense. So if number of zeros equals 2, then we did what we are doing, and therefore we can print it. And then I'm using something with zeros here. I'm guessing that the zeros array here is only accessed when see if the number of zeros is less than 2, I don't access it. Here I might. And here again only when, and then I don't think zeros are used anymore. It's going to the top. So all is good except for this little block. Can't do that block. However, if I find 1 0, I'm totally happy with setting my symbol to it. So here I have if can extend this, I think. It's either 1 or 0. It can only be 1 when we have at least 2 zeros. I mean, the zeros are index 0 or index 1. So if if W delta is larger than 0, then we're going to the right, and therefore we just must pick the larger 0. And if delta is W delta equals 0, then we didn't decide on the direction yet. So then we make the decision, and then if the approximation says that this 0 is less, the 0, 1 is less than the other one, then we go to we pick the second 0, and in all other cases we pick the last 0. The last 0 then at least must exist. So if the number of zeros is 1 or 2, that's actually this then. And then I have to set base 0 to 0 if we have only 1 0. Yeah, can't make anything else of it then. Adding a horrifying parenthesis miss. Base 0 is, oh, it fits on one line. So now in order to pick the 1, also the number of zeros must be equal to 2. And otherwise, well, we have at least 1 0, and then we just set it to 0, and we pick that 0, and then we use it. And then this is 0, and then we don't print that, but we still have a base 0, and we still set it here. So we just set W delta then. Now, the case of having no zeros at all, well, we still get here, I think, because we might get here, and now I still have to make the decision which way to go. Well, there are no zeros. I suppose that's just random. Oh, yeah, I was going to use the scale as a step. Let's use the same. Okay, else if number of zeros equals 0, we still have to do something. No, we still have to set a new sample. Yep, so new sample is something. And that decision is made by just pure the scale, right? I think the scale is set to something negative. Does it print it? Scale is positive here. Positive all the way. Scale is positive. Okay, so I don't know. Apparently, if we go to the left, the scale is positive. Pretty sure that I picked the scale negative if it's the other way around. Can actually test that. Maybe I should. Let's put starting point at -15. Oh no, my program is not compiling. So if the scale is positive, I want to go to the left. Could just continue in the same direction. And this is then going to be more like a change. So we subtract scale. I think that's correct. Yeah, it's good. Kind of random, but I think this works. Okay. Redefine works. Oh, it's using best 0, dude. That's so annoying. Int best 0. Pollute the stack longer, please. Just for debug output. Seriously? Yeah, I don't like that. No, let's do that differently. I'm testing here a number of zeros. Yeah, blah. So delete. What? Yeah. Put that there. Hey, now you know what base 0 is. Who needs to debug output here? Debug output test. Oh, this is 0 and number 0 equals 2. And since it's debug output anyway, I might as well use it, pass it here as a blip. Debug code. Shameless plug for libcwd here. So this only prints it when the debug channel notice is on and this condition is true. Compile. Nope. What did I change? Oh yeah, right. Put up. And it worked. So now we went to 6. So that looks like the step that it made is 1 in the same direction to the scale size that way. Yes. And there's no new parabola inside. Why did it not match a new parabola? Yeah, what? why there's no horizontal line here. I'm so confused. Is that the first time? What is the first time problem? Okay. So we find the thing again. Minimum doesn't change. The absolute step is super small. Try to fit a fourth degree. This doesn't have zeros. Now is it a real and a minimum? Yeah, I don't think so. That is also something that could be printed earlier, like here. Not going to do that now. Replacing history. Direction is set to up. Delta is set to -10. Maybe we should have printed here that we use the scale, but yeah, that's clearly scale. To best minimum set to, yep, re-add and close the sample, okay, and to history 0.6. Decremented, is that a word? Do sample with learning rate of 0.25 and slope -4 with 1. Well, whatever, because it's going in the right direction, 7. And apparently it's hanging, or it's just waiting for space before it calculates a problem. Let's press it. Yeah, okay. Strange moment to wait for space, I would say. But the parabolic approximation is again the same thing. Nothing changed. We tried going that direction, but nothing changed. And now we find that the minimum, no. We keep going in the same direction. You know, we are not interested in this minimum. We came from here. So now it's going to -21, which is outside. It's like, oh, there. It just plots it. Who cares? And yeah, it's going to keep doing that forever and ever and ever and ever, looking for a maximum. So let's humor it. 27, 42, ta-da, bigger, biggest, even bigger. I never had, I didn't realize these, oh, this is so interesting. I saw it before. Yeah, I've been doing this all day. It's so interesting. I mean, yeah. See, it now has a parabola point at 2 minus 2.5 times 10 to the power 46. That's really big number. I mean, it's like somewhere above here, but then, you know, a different Milky Way. Probably the other side of the universe. So far above here. And then it's calculating using the fitted parabola. It's calculating the parabola and round off errors. It's not this anymore, it's this. Can you imagine? This curve comes from the other side of the universe, and it's like missing it with, like, I mean, this is smaller than my finger, my hand. Really. No, I'm not saying that. And it wouldn't be true either. Yeah. Jeez. I have to go cook dinner, I think, because it's 8:30 and I didn't even eat breakfast, basically. Yeah. But it's still amazing, I think, that it really ends up like right in 0, 0. I mean, that's the reason, probably. It prefers to go to 0, 0 due to the round off errors. It's not just close to the correct parabola, it's infinitely precise, ending in 0, 0. That's probably the reason. Okay. I'm going to give you guys a link to another YouTube, which I saw today. Maybe it's old, I don't know, probably old. and you have to watch it till the end. In the beginning it's boring, like duh, but then it's at some point, and the point is 138, it's super interesting, really, really, really interesting. Let me find that. Copy link, paste. Yeah, it's a number file thing, but yeah, it's really interesting. So 100, I'll explain it quickly, but so 138, they factorize it. They take all proper factors and then they add all factors, and then you get a new number, which turns out to be larger than 138. So they factor that again and then add up all the proper factors of that new number, and then you get well, a new number, and so on and so on. It takes a really interesting while before that goes down to 1. And then the video becomes interesting. Really, watch it. I'm going to make